Good evening, welcome to SAKALAVIDYA YouTube channel. Okay, Namaste, good morning all. Sorry, good evening all. Good evening, good evening. Right. Today we'll discuss complex numbers. Okay, this will be very useful for Eamcet as well as Eamcet also. In Eamcet, actually, two questions will appear from this chapter. Two questions will appear from this chapter, whereas for Eamcet it has more weightage. It may have 3 to 4 marks. Okay, right. Good evening. Okay, let me give the introduction today. So first, let us consider x square plus 1 is equal to 0. Okay, we need to solve x square plus 1 is equal to 0. How to solve x square plus 1 is equal to 0? And now plus 1 take this side. You get x square is equal to minus 1. Now we get x is equal to square root of minus 1. So far actually we have not discussed about square root of a negative number. So that's why here this negative number, the square root of negative number minus 1 is considered as I. This I is known as iota. Iota means imaginary, or this is also called root of minus 1 is also called imaginary unit. So now this x is equal to, you can write I. I is the imaginary number. So for example, I is the root of this equation. That's why now note we get important point. See, x square is equal to minus 1 we have. Substitute I here. Therefore, we get I square is equal to minus 1. You get this relation. I square is equal to minus 1. Okay, understood now. Hereafter in this chapter, wherever I square is there, we need to take minus 1. So minus 1. So now, so let us discuss integral powers of I. This is very important concept. Integral powers of I. So let us discuss first integral powers of I. What is the integral powers of I means? See, we know that I is the imaginary unit whose square is minus 1. I square is equal to minus 1. Now let us find out I cube. I cube means we can write this is I square into I. I square is minus 1, so we get minus I. I power 4, I raised to 4. So then this can be written I square times I square. You get minus 1 times minus 1. Minus into minus plus. So you get plus 1. Even I raised to 5. That's why integral powers of I. I raised to 5 means I to the power of 4 into I you can write it. So that is I. I to the power of 6. I to the power of 6 means I to the power of 5 into I. I into I. You get I square. I square is equal to minus 1. Understood now? So like this we shall get it now. I square, I cube, I power 4, I power 5, I power 6 we can find out. So next now you check one thing. I square plus I cube plus I to the power of 4 plus I to the power of 5. How much this value? What is the value of this one? What is the value of this one? So I square equals to minus 1. I cube is equal to minus I to the power of 4 is equal to plus 1, I to the power of 6 is equal to how much? I to the power of 5 is equal to I plus I. What happens now here? 1 gets cancelled, I gets cancelled. We get 0. That means you remember one thing. Whenever 2, 3, 4, 5 are order in consecutive numbers, then that powers will be 0. Directly we can write 0. So that means I give one more thing. I cube plus I power 4 plus I power 5 plus I power 6. How much you will be getting? Absolutely 0. Even see, let us check one more example also. Now I to the power of 2020 plus I to the power of 2021 plus I to the power of 2022 plus I to the power of 2023. Don't worry, 2020, 2021, 22, 23 are 4 consecutive numbers. Then this will be 0, obviously 0. Okay, understood now. So now, how to find the value of I raised to n, where n belongs to natural number. Some bigger numbers are there. How to find out? Is there any technique for that one? See, shortcut we have, that I will explain. Shortcut. So in order to find that one, step 1 first, what is the step 1 means? Divide n by 4. Step 2, let remainder be r. For example, if you divide this n by power by 4, remainder be r, then step 3, this I to the power of n is equal to I to the power of r. I to the power of r. That means where r value will be like this, either 0, r1, r2, r3. So this we need to remember these values. What are the values we need to remember? I to the power of 0 means 1, you remember. I to the power of 1 is I square is equal to minus 1, whereas I cube is equal to, you remember that, minus I. These values we need to keep in mind. So that means now I will give some examples. Let us do examples. First one, the value of I to the power of 320. I to the power of 320. The value of I to the power of 320. So how to find out I to the power of 320? Don't worry. What is the procedure we need to follow? First, divide 320 by 4. So 4 8 is 320. What is the remainder you get? 0. Here r value is equal to 0. Therefore I to the power of 320 equals to I to the power of 0, which is equal to 1. So hence this I to the power of 320 equals to 1. Okay, now I give one more example. Second example. Second example. The value of I to the power of 2019. Anybody, what is the value of, just practice it. I to the power of 2019. Anybody? I to the power of 2019. What shall we do? Divide 2019 by 4, take the remainder. So remainder equivalent to the this power remainder. So that means what is the solution need to be done here? First divide 2019 4. See 450 ja 200. Am I correct? 19 you will get it. 4 4 ja 16. You get remainder 3. That means here this is the R value. Therefore I to the power of 2019 equivalent to I cube. I cube means we can write I square into I. So minus 1 into I, whose value is minus I. This equals to minus I. Now I'll give one more question now. Third one. The value of I to the power of 2021. Value of I to the power of 2021. Anybody? I to the power of 2021. Now here see the solution. Here tip is 2021 should be divided by 4. 450 ja 200. So 21 you get it. 4 5 ja 20. So remainder is 1. That means R is equal to 1. Therefore I to the power of 2021 equals to I to the power of 1. I, that's all, equal to I. All of you understood? So I will give some problems as quick as possible. You need to tell me. I to the power of 243. I to the power of 355. I to the power of 1000. I to the power of 2018. You give me the answers now. Give me the answers. Okay. Just think. These values. Okay. Right. Okay. Right. So let us go to the fourth example now. The value of I to the power of 4n. Here n belongs to n. That means n is a natural number. What is the value of I to the power of 4n? I to the power of 4n. That means generally we do the solution like this. 4n divided by 4. 4n times 4n. Remainder is 0. So therefore I to the power of 4n equals to how much? I to the power of 0, 1. So similarly you remember now. I to the power of 4n plus 1 is I. I to the power of 4n plus 2 is minus 1. I to the power of 4n plus 3 is minus I. That means I can list out all these things here. You remember, I to the power of 4n equals to 1. I to the power of 4n plus 1 is 1. 1. Remainder is 1. I, you get it. I to the power of 4n plus 2 equal to I square minus 1. I to the power of 4n plus 3 equal to I cube is minus I. These are very, very important, you remember. And one more result also you will get it, very, very important result. I to the power of 4n plus I to the power of 4n plus 1 plus I to the power of 4n plus 2 plus I to the power of 4n plus 3 is always adding. 1 minus 1 cancel, I minus I cancel, you get 0. This wonderful result you will get it. This result, just note down, it's an important result. Right, understood now all of you? Okay, now let me move to the definition of the complex number. What is the definition of the complex number? So now, so far we have discussed about only imaginary number, imaginary unit, and properties of the imaginary unit we have discussed. Simple. Okay. Now the definition of the complex number. Understood all of you? I hope everybody will understand. Now let a comma b be two real numbers. They are not imaginary, real numbers. Then the number of the form A, real number plus imaginary number. Real number plus imaginary number. A complex will be formed. Complex between real number and next imaginary number. That is called complex number. From A plus IB is called a complex number. Denoted by Z. That means Z is equal to A plus IB. Z is equal to A plus IB. That means you can write like this. Complex number is equal to real number plus imaginary number. Is called complex number. This is real number plus imaginary number. That means now hereafter in Z is equal to A plus I, we can name A and B. Okay, let us discuss now. Next. So now let Z is equal to A plus IB. Then A is called real part of Z. And B is called not BI, not IB. B is called imaginary part. So now we can denote like this also. Real part of Z. Shortly we can write RE of Z. So RE of Z is equal to A. imaginary part of z equal to Im of z is b. Don't write I. B. This is called real part. This is called imaginary part. Understood now? So now I will give some questions. You need to answer now. I will give some questions. You need to answer now. Okay, examples. Let us discuss examples. Examples. First example. The imaginary part of z is equal to 3 plus 4i is first option 3, second option minus 3, third option 4, fourth option minus 4. So which is the right option? Which is the right option? Which is the right option? Chetan Chandra. Very good, very good. Fourth option, fourth, right. Now solution. See, imaginary part of z, Im of z is equal to 4. This only you need to write. Okay, one more question I will give it. The real part of z is equal to minus 5 plus 3i is first option 5, second option minus 5, third option 3, fourth option minus 3. Okay. What is the Tagore? What is the answer for second one? What is the real part of z? What is the real part of z? Tirupati, Momaya, Suma, Venkata, Balu, Umshi Krishna Yadav, Ishwar, Golapelli, minus 5. Very good, Ishwar. Sumant, Jhinka. Right. Now let us write. Now the solution. Real part of z equals to, so this one is the real part. So minus 5. Second option is the right option. Now third example. The real part of z is equal to 7i is first option 0, second option 7, third option minus 7, fourth option 1. So which is the right option now? See the question, third question now. Third question. Chetan Chandra, 0, 0, 0. Okay. Venkat. Right. Bunny. Option 1. Very good. Option 1. Okay, let us see. Now this z can be written like this. Imaginary part is not, real part is not there. 0 plus 7i you can write it. So therefore we are asked real part. Real part of z is equal to 0. So now some important points to be noted. Note down. Here note. Let z is equal to a plus ib and a is equal to 0. That means real part of z. Real part of z equal to 0. Then z is purely imaginary, purely imaginary. If real part of z is equal to 0, then it is called purely imaginary. Okay. Fourth example. The imaginary part of z is equal to 5 is first option 5, second option -5, third 0, fourth 25. Okay, right. What is the imaginary part of z is equal to 5? Here see, z equals to, we can write 5 plus 0 multiplied by I. Therefore, imaginary part of z is equal to 0. So, third option. So, you can remember one important point now. You can note one important point. Let z is equal to a plus ib and imaginary part of z, that is b, is equal to 0. Then z is purely real. Purely real. Purely real. Purely real. Okay, these words: purely imaginary, purely real. Purely real. Okay, next concept. Next concept is very, very important concept. Okay, you may be new, no problem, no problem. Next concept. Modulus of a complex number. Modulus of a complex number. This is very, very important. Modulus of a complex number. How to find out modulus of a complex number? This is very important. Modulus of a complex number. See, let z is equal to a plus ib, then the numerical value root of a square plus b square is called modulus of z, denoted by mod z. Therefore, mod z is equal to mod of a plus ib equal to root of a square plus b square. So this can be remembered like this also: root of real part of z whole square plus imaginary part of z whole square. Am I correct? So mod z we can remember like this: under root of a square plus b square. Okay, this is real part of z square plus imaginary part of z square. This is called modulus of a complex number. Modulus of a complex number. So let us solve some examples now. Examples. Modulus of 3 plus 4i equal to, modulus of 3 plus 4i equals to, what is the modulus of 3 plus 4i? What is the modulus of 3 plus 4i? imaginary part square plus real part square. Okay, now solution, let us say z is equal to 3 plus 4i. Okay, mod z equal to what we need to write? Root of imaginary real part 3 square plus imaginary part 4 square. This will be root of 9 plus 16. This is root 25. You get 5. Okay, I give one more question. You try it now. Second question. Modulus of 5 plus 24i. This takes 7 plus 24i. You take it 7 plus 24i. 7 plus 24i. What is the modulus of this complex number? Good. Nani, good. Suma, good. Playboy money. Okay. Got it, all of you? Right. Swati Singh. Narla, not getting. Okay, Suma, one time is enough. Right, very good. So that means your solution, directly I am writing root over 7 square plus 24 square. So 7 square is 49 plus 24 square is 576. That means we get root of 625 whose value is 25. Square root of 625 is. Okay, understood now? Okay. Now I will switch over to the next concept. Conjugate of a complex number. Conjugate of a complex number. Conjugate of a complex number. Next concept is conjugate of a complex number. The money, are you following or not? Okay, no problem. So conjugate of a complex number. Let z is equal to a plus ib, then a minus ib. Just change the sign of imaginary part. If plus is there, minus is there, plus. So then a minus ib is called conjugate of a plus bi, denoted by z bar. That means here you remember, if z is equal to a plus ib, then z bar is equal to a minus ib. Here one interesting factor. What is the interesting factor means? Here mod z equal to root of a square plus b square. What is mod z bar? That is also root of a square plus minus b whole square. This is also root of a square plus b square. That means both moduli are equal. That means mod z equals to always mod z bar. Understood now? Modulus of a plus ib and a minus ib both will be same, equal. Mod z is equal to mod z bar. Mod z is equal to mod Z bar. Now I will give some examples you need to do now. Okay. Examples. The conjugate of 3 plus 4i. Okay, I will check your answers. 3 plus 4i. 3 plus 4i is. What is the conjugate of 3 plus 4i? What is the conjugate of 3 plus 4i? Anybody? What is the answer? You need to chart it now. Wonderful, Revati. Okay, Chetan Chandra, Yashwant, Nani, Narla, Balu, Lakshmi Bai, Prasad, Chinnu Patel, Venkatesh Avala. So today any new viewers are there, please subscribe, all of you, like, subscribe and share. You need to do it. Okay, Ishwar Gollapelli. Right. Kottapelli. Hemasri. Harshita Jonnada. Right, thank you, thank you. Now this is my choice now. Let us say Z is equal to 3 plus 4i conjugate Z bar. Just change the sign, that's all. Change the sign of imaginary part itself only. So now I ask you one question now. The conjugate of 3 minus 5i is 3 minus 5i is. Yes, this is actually meant for Eamcet only. Eamcet and Mset both. Okay. 3 minus 4i. Right, 3 plus 4i. Solution. Let us say Z is equal to 3 minus 5i. Therefore, Z bar is equal to 3 plus 5i. Now I give some examples, you try now. Conjugate of minus 2 plus 3i. Conjugate of minus 2 minus 3i. Conjugate of 2 minus 3i. Conjugate of 2 plus 3i. So conjugate of this one, conjugate of this one, conjugate of this one and conjugate of this one. Write down in your notes. Conjugate of. Conjugate of. Okay, wonderful practice, everybody. Okay. Right. Next concept, additive inverse of a complex number. Additive inverse of a complex number. Additive inverse of a complex number. What is the additive inverse of a complex number? Suppose see, let Z is equal to a plus ib, then multiply both real part and imaginary part with minus sign. Minus a minus ib is called the additive inverse of a plus ib. denoted by minus z. Therefore, additive inverse of z equal to minus z. That's all. Okay. Okay, I have the work. In the 7:30 we don't have any class. Tomorrow. Right. Now I will give some examples. You try. Write additive inverse of first one 2 plus 3i, second 3 minus 4i, third minus 5i plus 7i, fourth minus 7 minus 24i. Write the additive inverse of 2 plus 3i, 3 minus 4i, minus 5 plus 7i. 4 questions I have given. 4 questions I have given. No, tomorrow not morning class, only 4:30. 4:30. No, not yet completed. Yet to be completed in the morning session. That will be completed. Right. Everybody is correct. Right. Wonderful. Good job. So for this one, 2 minus 2 minus 3i. For this one, minus 3 plus 4i. For this one, 5 minus 7i. For this one, 7 plus 24i. Correct? Have you checked all of you? Thank you. Now, multiplicative inverse of a complex number. Multiplicative inverse of a complex number. Multiplicative inverse of a complex number. Right. Right, Chetan Chandra. Let z is equal to a plus ib, then 1 upon a plus ib is called the multiplicative inverse of z. Okay, that is 1 by z. Therefore, multiplicative inverse of z equal to 1 by z. But in the examination, answer will not be in the form of 1 by z. That will be in the form of a plus ib form. That we need to check it now. So let's have some practice session now here before going to find out. Now I ask you one question. What is a plus ib into a minus ib? So what is the product of these two? A plus ib into a minus ib. So what is the value of a plus ib into a minus ib? Vaishnavi Rati Devi, after long time. Where had you been, Vaishnavi? Now we have one important formula from algebra, a plus b into a minus b, which equal to, everybody knows, a square minus b square. So that means this can be written now, a square minus ib whole square. We get a square minus I square b square. Already we had a discussion, I square is minus 1. So a square of minus I square means plus b square. So for example, this is z, this is z bar. Z into z bar is equal to mod z square. We get a one important note. Important note, we will get it. Important note. For example, this is z. We know this is the conjugate complex number. This will be the mod z square. Therefore, z into z bar is equal to, we can write mod z square also, or mod z is equal to, we can write root of z into z bar. This is very important concept we derived. Right. Now, okay, one question I will ask. Let me ask the one question. Examples. Multiplicative inverse of 3 plus 4i is multiplicative inverse of 3 plus 4i. See the solution. First I complete one problem. After that you may do it. Let z is equal to 3 plus 4i. Multiplicative inverse is 1 by z. 1 upon 3 plus 4i. But what we need to do? Now we need to conjugate. Conjugate means multiply with the conjugate complex number. That is 3 minus 4i. Am I correct now? 3 minus 4i. So 3 minus 4i into 1, 3 minus 4i upon this already we discussed. What we have discussed here, see, z into z bar is equal to mod z square. So that means we can write this is, what is mod z? Mod z is equal to root of 3 square plus 4 square. That is root of 9 plus 16. Root 25. Root 25 is equal to 5. Here mod z square we need to write. That means 25. This we can separate it like this. 3 upon 25 minus 4 upon 25 I. This is the multiplicative inverse of 3 plus 4i. 3 plus 4i. Okay, shall I give one more problem? Second problem. Multiplicative inverse of inverse of 7 minus 24i. 7 minus 24i. 7 minus 24i. So now I ask you one question. In this now session, how many Eamcet students are there? Eamcet. Raise your hands. All of you just chart it yes, 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 like that. How many Eamcet? Mohana Krishna. Okay, yes, Ramya, right, yes. Akhil, right, only 1, 2, 3, 4, 5, 6, 7, yes, 8, 9, right. One time only, one time only. It's not Eamcet, it's Eamcet only. Both Eamcet and Eamcet, both are same chapter, common chapter I have started. Common chapter I have started. This is the common chapter. Right. So now, right, thank you, Vanadal, thank you. So now, let Z is equal to 7 minus 24i. We need to find out 1 by Z. Okay. 1 by Z. 1 by 7 minus 24i. Multiply with 7 plus 24i upon 7 plus 24i. Now, 7 minus 24i into 7 plus 24i is mod Z square. Mod Z find out first of all. Mod Z is equal to root of what? 7 square 49, 24 square 576. This will be square root of 625. This will be 25. This is mod Z square. 7 plus 24i by mod Z square is 625. So 7 upon 625 plus 24 upon 625i. Okay, now you are able to find out this multiplicative inverse, additive inverse. Already we have discussed so many concepts. Okay, I ask you one question here now. What is 1 plus I whole square? What is the value of 1 plus I whole square? What is the value of 1 plus I whole square? Srija Bodala, actually, I think after a long time, actually, I have been observing you in the classroom. Please don't chat like that. Already I got it in mind. Please don't chat again. Okay. Right. What is 1 plus I whole square? See, 1 plus I whole square means you need to use a plus ib whole square. That is a square, 1 square, 2ab, 2 into 1 into I plus I square. Very interesting this is. 1 plus 2i, I square is minus 1, both cancel, you get 2i. Now find 1 minus I whole square. What is 1 minus I whole square? What is 1 minus I whole square? So whether it may be Eamcet or Eamcet examination, but you need to remember this one. This will be very, very important. You need to remember 1 plus I whole square means 2i. What is 1 minus I whole square? Why should I do? I will explain. I will come to the application part. Yes. This will be what? A minus b whole square formula. 1 square minus 2 into 1 into I plus I square. B square only. 1 minus 2i minus 1. Plus 1 minus 1 cancel, minus 2i. Please all of you remember these two. You list out like this. 1 plus I whole square is 2i. 1 minus I whole square minus 2i. During main sessions, I won't repeat again this one. You need to remember it. You need to remember. 1 plus I whole square is equal to I. 1 minus I whole square is equal to I. Okay, I will give one more. What is 1 plus I into 1 minus I? What is 1 plus I into 1 minus I? What is 1 plus I into 1 minus I? Anybody? This is actually mod Z square. Mod Z square means 1 square plus 1 square. Imaginary part also 1 square. 1 plus 1, 2. 1 plus I into 1 minus I is 2. So that means you remember this one also. 1 plus I into 1 minus I is 1 minus I square, that is 2. So these points remember in your mind. Okay, now I give one important question. How many of will do? I will check now. Example. This type of question may be asked in the examination. The value of 1 plus I by 1 minus I equal to A plus IB. Then the value of A plus B equals to first option 1, second option 2, third option 0, fourth option -2. So now you do this problem. Okay, you think. Right. Okay, multiply both numerator and denominator with 1 plus I, because the conjugate of 1 minus I is 1 plus I. So now this can be done like this. 1 plus I upon 1 minus I multiplied by 1 plus I upon 1 minus I. 1 plus I, sorry. This will be 1 plus I whole square. This is mod z square. This is 2. See, in this case, this is 2. What is 1 plus I whole square? 2I. So this will be 2I by 2. This is I equal to A plus IB. Comparing on both sides. Here A is 0. No real part in this one. A 0. B is 1. We are asked A plus B. A plus B is equal to 0 plus 1. 1. That means first option is the right option. First option is the right option. Okay, this type of question may be asked in the examination also. Second question I will give it, you try to solve it. The value of 1 minus I by 1 plus I equals to P plus IQ. Then P square plus Q square equals to first option 2, second option -1, third option 1, fourth option -2. You try this question, all of you. I want the solution now. Okay. Okay, all of you check. So let me complete my method now. Solution 1 minus I by 1 plus I multiplied by the conjugate of 1 plus I is 1 minus I. 1 minus I upon 1 minus I. This is 1 minus I whole square. Upon this will be z into z bar is mod z square is 2. This will be -2I upon 2. So actually I minus I you will be getting. So you need to compare with P plus IQ. There is no, this is purely imaginary. That means real part is equal to 0. Imaginary part Q is equal to -1. What we are asked? P square plus Q square. 0 square 0, -1 square plus 1. 1. So answer is 1. So now hereafter all of you remember this one also. 1 plus I by 1 minus I is I. 1 minus I by 1 plus I minus I. Please remember these points. This will be very, very important. Okay, now I give one question, you try to solve it. Third, the value of 1 plus I by 1 minus I whole to the power of 2020 equals to first option 2020, second option 2019, third option 1, fourth option -1. Sorry, third option I. This is +1. So this will be the actually slowly the level will increase like this. If you know the concepts, with the help of concepts this problem can be solved with a fraction of second. See, 1 plus I by 1 minus I is nothing but what? I. That is nothing but I to the power of 2020. I already discussed I to the power of 2020. Yes, it might be previous Eamcet question or previous ICET question also. So how to solve this one now? Solution. We know that 1 plus I upon 1 minus I, you need not simplify, directly you can remember I. Therefore I to the power of 2020 need to find out. Now shortcut, 2020 should be divided by 4. 450 ja 200, 20, 4 5 ja 20, remainder is 0. This equal to I raised to 0 is 1, absolutely. So that means fourth option is the right option. Fourth option is the right option. Okay, thank you one and all. Bye. See you. I hope you might have enjoyed this class. Now I request even the ECET students and MCET students, all of you give your feedback after completion of this session. So you will get below description box you may find comment section. In that comment section today I need more than 50 suggestions I should get from you. So tomorrow morning the class is meant for absolutely MCET students only. That is 9:30 class. That is combinations will be continued. But this session is meant for both the sessions, ECET as well as MCET classes. Whenever MCET, definitely I will bifurcate the classes. Thank you one and all. For ECET students 4:30, for MCET students also 4:30. Tomorrow also basic classes will be discussed. After that both the classes will be get separated. Okay. Thank you. See you one and all. Bye bye.